The first thing I like to do with these normal distribution problems are draw the distribution to see what I'm looking for. So in this case, we have the normal distribution. Picture will always look like that. But we want to find the z-scores that separate the middle 13%. So there's some value of z here and here, or somewhere. We'll call them z1 and z2, so that the middle percent here, the area, is 13%, or 0.13. inside between those two. So there's two approaches we can use. They both require that we find the area to the left of the first z value. That's because the calculator and the table both are based off of areas to the left of z1. So let's find area left of z1. It's kind of tricky in that we have to remember that the whole curve, like all of this area here, is 1 altogether. But we take out the 13%, or minus the 0.13, because that's the part that's in the middle. So 1 minus 0.13 makes 87, I'm pretty sure, is the amount of area left over. Let's make sure it didn't make a silly error. Yeah, 87. So that's the area that's not between the two z values, and then we'll have to divide that thing by 2 because it's in two tails. It's symmetric, right? So half of the 0.87 should be to the left of z1 and the other half will be to the right of z2. If the calculator comes back and take that number and divide it by 2, we get 0.435. is the area to the left of z1, just because total area is 1 minus the area in the middle and then divided by 2 for the symmetry, the two areas. Then by the table version, we have to find that 0.435 inside here, inside the standard normal table. 0.435. So, down here, this table starts with the positive. Those are 0.5 values. We need a little bit less than that, like down here. 0.43. So 42, 41, 40, 44, 4364, 4325, 4286. This guy, 436, is closer than 0.4325. You can always do a quick subtraction to make sure you have what you want. We want 0.435, and the closest we could get would be like 0.4364 there, or 0.4325. Just to see which one's closer, maybe just line them up there and say, okay, this guy's only off by 1 in that third digit, where this guy was off by 3 in the third digit, so that's the winner. The 0.4364. Let me make that a little more clear from my search. 4364. That's the closest we can get to the area of 0.435. Now we reverse use the z table. So find the first digit of z from the row, negative 0.1, and the last digit from the column, 0.6. So here we see that z1 is negative 0.16 from reading the z table, or we could put it over here. If we use symmetry, the middle, it has to be in the middle, so this z value is negative 0.16 means that z2 will just be the positive value of that. And that's how you would use the table to do it, or we could do it with the calculator by using the inverse normal function, second distribution. Number 3 is the inverse normal. That will spit back a value. The area to the left of the z we want is 0.435. By that same calculation, 1 minus the middle divided by 2. The mean is 0 and the standard deviation is 1 for the normal distribution, the standard normal distribution. So after we press enter, you get negative 0.16. You see that this is more accurate than the table. We have more decimal places, but the first two digits are the same if we round them correctly.